Dear students, in last class we studied the advantages and disadvantages of aluminum conductors. The main advantages of aluminum conductors are low weight, high conductivity, and the low cost. And the disadvantages are low tensile strength, high coefficient of thermal expansion, and large area. To overcome these disadvantages, that is to increase the tensile strength, which is most required property of aluminum conductor, one or more central conductors of different material are used. These metals which are used at the center of aluminum conductor will be having higher tensile strength. In modern overhead transmission systems, bare aluminum conductors, that is without any insulation, are used, and these bare aluminum conductors are classified as all aluminum conductor, all aluminum alloy conductor, aluminum conductor steel reinforced, aluminum conductor alloy reinforced. Now write down these points first and then we will continue. To increase the tensile strength of the aluminum conductor, one or more central conductors of different metals having high tensile strength are used. In modern overhead transmission systems, bare aluminum conductors are used. Which are classified as AAC, that is all aluminum conductor. If you look at the cross section of such conductors, you will be able to see only the aluminum strands. So these all are aluminum strands. AAAC, all aluminum alloy conductor. In structure, these conductors appear like all aluminum conductor only, but the strands here are made up of alloy of aluminum. I hope you all know what is an alloy. Alloy is a homogeneous mixture of two or more than two metals or metal and non-metal. Alloying is done to obtain the required properties which are not there with a single metal. Strands of alloy of aluminum. Next class of aluminum conductor is ACSR, that is aluminum conductor steel reinforced. Here in such conductors, a central steel conductor is used. Here this conductor is steel conductor. All around this steel conductor, aluminum conductors are placed. You can call these small conductors as strands here. Last class of aluminum conductors is ACAR. ACAR means aluminum conductor alloy reinforced. In these conductors, central conductor is of aluminum alloy or any other alloy. So here we can write alloy of any metals, and around this central strand there will be aluminum conductors. Among all these classes of aluminum conductors, ACSR conductors are most widely used type of conductors. Among the above mentioned, four types of aluminum conductors ACSR is widely used type of conductor. Reasons for this are as follows. See, the aluminum conductors with steel reinforcement are for same resistance and lifespan Aluminium conductors with steel reinforcement are cheaper than copper conductors. When we reinforce the steel in aluminum conductors, the mechanical strength becomes very high, that is higher than copper conductor. Therefore, we can increase the distance between two supporting structures, that is, we can increase the span of conductors. If we increase the span of conductors, then the cost of erection of towers, or indirectly the cost of erection of transmission systems and their maintenance will decrease. By high mechanical strength, the length of span, I hope you all remember, the length of span means the distance between two supporting towers or the poles. Can be increased. And cost of erection and maintenance can be reduced. Third one, coronal loss and skin effect are reduced. Coronal loss we have already studied. So I just ask you to relate coronal loss with the radius of conductor to find out whether coronal loss is inversely proportional to the radius of conductor or not, right? Here I will define what is skin effect. The alternating current flowing through the conductor will not be distributed uniformly across its cross section. That is, the current density near the surface is more than near to the center. If I take a conductor, the current density near the surface is more than near the center. Here we will find more density of current like this. But near the center it is very less. And if the frequency of the current increases, then the density near the current density near the surface will further increase, and at the center the current density will further decrease. This effect is called as skin effect. This effect is called as skin effect. So you just note down the definition of skin effect. The alternating current distribution in a conductor is not uniform. The current density near the surface is more than near to the center. It is affected by the frequency of the current. If the frequency of current is more the current distribution is more non-uniform. This effect is called skin effect. This effect is called skin effect. Representation of transmission line. In single phase transmission system, there will be two conductors which will be running parallel to each other. This single phase transmission system, for the study purpose or for the analysis purpose, will be represented by a series combination of AC resistance R and inductance L and shunt combination of conductance G and capacitance C, wherein one set of R, L, G and C forms one section. Such many sections are added to get the full length of transmission line. The conductance of transmission line represents leakage loss at the insulators of the supports. We have studied that insulators will be having some capacitance, and over the surface of insulators a very small quantity of current will be flowing, which we call as leakage current. Due to that leakage current, there will be some losses. So to account for that, we take the reciprocal of the equivalent resistance due to which leakage losses occur as shunt conductance. The three-phase transmission line can also be represented as a single phase equivalent representation if and only if the line is balanced. For analysis purposes, a single phase transmission line can be represented by series combination of AC resistance R and inductance L and shunt combination. Shunt combination means parallel combination. Conductance is denoted by G and capacitance by C. As shown in figure above. Where small sections are added together to form full length line, together to form the full length line. You please write here section 1, section 2, section 3 dash dash dash. The conductance of transmission line, that is G, represents leakage loss at the insulators. Mounted on supports. Three-phase transmission line can also be represented as a single phase equivalent representation. But for analysis purpose here, we will be taking all the per phase values, that is voltage per phase, current per phase, resistance per phase, and so on. If the line is balanced, the transmission capacity, that is how much power at the given voltage, mainly depends on the inductance and capacitance, because the resistance and The conductance are very small. The resistance used for the analysis of transmission line performance is the effective, that is AC resistance. The direct current resistance, that is RDC, of a conductor is defined by RDC equal to rho L upon A, which you have studied already in your 10th standard and your PU level. The transmission capacity of a line mainly depends on the inductance and the capacitance. As resistance and conductance are very small. For the analysis purpose, AC resistance of conductor is considered. The direct current resistance RDC of a conductor is defined as RDC is equal to rho L upon A ohm. RDC equal to rho L upon A ohm, where rho is resistivity of material, used to make the conductor. L is length of conductor and A is cross-sectional area of conductor. L is length of conductor and A is cross-sectional area of conductor. Dear students, today I will stop the class here and continue in next class with the inductance, Ampere's law, and magnetic intensity inside and outside the conductor. Thank you. Thank you very much.